Good evening, students. This is Vilash Kumar. Today I am continuing the lecture of operating system. The topic for today is virtual memory. I have already shared about the memory management with some PDF file, and the link of that will be available on Google Classroom, which I have already shared the code among the student class group. Now the next topic, which is virtual memory. So what is virtual memory? As I already discussed this virtual memory in the class. Once again I am repeating. Now it is more elaborate. Now the virtual memory is in more elaborate form. What actually the virtual memory is? It is a space that where large program can store themselves in the form of pages, while their execution and only the required pages or portion of processes are loaded into the main memory. This technique is useful as large virtual memory is provided for user when a very small physical memory is there. Means there is an illusion should be created among the user that user have very large amount of memory, but in actual it is not so large. The main memory is not so large. For example, I have given some example. Something which appears to be present but actually it is not, that is called virtual memory. Means that we actually have 4 GB memory, real memory of computer. This is RAM, and but the user through the virtual memory user use as it is 16 GB. It just gives the illusion to the user. A program can write a programmer can write a program which require more memory than the capacity of main memory. Such a program is executed by virtual memory technique. This technique is called a virtual memory technique, in which the user have the illusion that it is using 16 GB memory, but in actual it is only having the 4 GB memory. How this process will take place, that will be discussed in today's lecture. So what are the points to be remembered for the virtual memory? There are a few points which I have created which should be remembered with the virtual memory. User written error handling routines are used only when error occurred in the data or computation. When any error regarding to the memory is occurred, that can be solved with the virtual memory. Certain options and features of a program may be used rarely. Means if any program is diminished due to the memory, that can be rarely happen in the virtual memory case. Many tables are assigned a fixed amount of address space, even though only a small amount of table is actually used. What actually the table work in this memory system, that will be discussed elaborately with the diagram. The only purpose of this line is that in actual the memory which is using, that will be a small amount of memory, but for the user the illusion is to be created that it has a large amount of memory. The ability of execution of a program that is only partially in memory would counter many benefits. Means the execution or using virtual memory has many benefits. Less number of input output would be needed to load or swap each user program into the memory. Means less number of input output resources are required when we have the virtual memory criteria. A program would no longer be constrained by the amount of physical memory that is available. Means there is no issue of physical memory regarding the program when virtual memory form is available. Each user program could take less physical memory, and program could run at the same time, which corresponds to increase in CPU utilization and through output. With the virtual memory, the through output and the CPU utilization is also increases. Now, how the virtual memory is implemented, that actually I am going to explain with that diagram. Suppose that the virtual memory storage is assigned in the pages form, page 0, page 1, page 2, and up to page n. CPU is interacting with the virtual memory, and virtual memory means a user interacted with the memory map. If CPU is requesting any of the page, any of the thing demands from the memory, so memory map could send the message to the physical memory. Physical memory is the main memory, means RAM, and also send it to the disk. Disk is the secondary storage or our disk storage. If that particular demanding page is available in the physical memory, then it could be assigned to the CPU. But in condition if that page is not available in the physical memory, then it demands that particular page from the disk. Disk means secondary storage. So it demand particular page from the disk. Memory map chap, either it is in physical memory or it only send the message to both the memory, physical memory, disk memory. If that will be available in the physical memory, that will be assigned to the CPU. But in any case, if physical memory is full, it already have more lots of content and not able to assign any other which is demanded by the CPU. So the thing is to be done, that is called the replacement. Replacement means physical memory take that particular page from the disk and assign some of the frame which is not using particular at that time, that will be copied or that will be swapped with the disk. Means the paging which is demanding by the CPU at current time, that will be loaded in the physical memory, and the frame which is not actually right now needed, that will be swapped with the demanding CPU page. Means there will be a swapping process. Swapping process means the actual CPU requirement will be assigned in the physical memory if it is not available in physical. If it is available, then it directly assigned it to the physical memory. So virtual memory can be implemented by demand paging or demand segmentation. What it is, that will be discussed in the next. Demand paging. The process resides in secondary memory and pages are loaded only on demand, not in advance. Means if that particular page is available in the memory, then it will be assigned to the process P1. But if that particular P1 process is requiring some pages that is not available in the main memory, then on demand it will be loaded in the main memory. How it process will be happen? Suppose that CPU is demanding P1 process. P1 process contain ABCD, and that also contain the copy ABCD, and P2 contain EFGH, and P3 contain I to R. Earlier main memory is, whenever we boot the system, earlier main memory is free. It doesn't contain anything. But as the CPU is demanding the particular things, then it will be swapping that, that it will be copying that particular content from the secondary memory, means disk, from the disk. But in case if the memory is not have enough space in the main memory, then it start the process of swap in swap out. Swap in swap out means that any of the process which is executed earlier, it contains the pages EFGH, that particular page is not used at that time when P1 is demanding. P1 is demanding ABCD. So swap out means that EFGH is to be swapped with the secondary memory, means that particular EFGH pages is to be stored in the secondary memory, and the currently required process ABCD is to be swapped in the main memory. Means the CPU uses P1 process which contain ABCD page, that will be swapped in, and the not using process EFGH pages, that will be swapped out with the secondary memory. This is called demand paging. Here is one more line of demand paging. Right now, if after P1 process CPU is demanding the E, means P2 process E page is demanding. If the page is not present in the main memory, then we call it as a page fault. As earlier in earlier example, that we have swapped out the particular page in the secondary memory, so it is not available in the main memory. So this occurrence is called as the page fault, means that particular process, that particular page is not available in the main memory. Now the page fault, as I have discussed, that particular page is not available in the main memory, this situation is called the page fault. The demand page is not available in main memory, then we can call it as a page fault. Page fault can be handled by operating system, means if page fault occur means that the particular page is not available in the main memory, then operating system will deal with that request of CPU. So here is some point. First point, operating system looks at the PCB to decide. PCB means process control block, then the control transfer to the operating system. Operating system will check invalid reference. Invalid reference means that particular page not available either in the main memory or in the secondary memory, then it will abort the process. There should be availability of the page either in the main memory or in the secondary memory. If that particular page is available in the secondary memory, means in disk memory, just not in the main memory, then it will start the load the page again. I will show you with the diagram how this process will work. After that, get empty frame. It will provide the empty frame for loading that particular that particular page in the main memory. Swap page into frame via disk operation. Reset page table to indicate page. After that, acquiring the particular page from the disk to the main memory, there should be a frame assigned, there should be a page table assigned to indicate, and restart the process for indication. Suppose here is the steps for handling the page fault. With this diagram I have certain things. This is the demand of the page, load M. If that first point, first it goes to the page table. Page table, if that particular demanding for the page I, if that particular page is not available in the page table, fine, then the control goes to the operating system. Operating system checks in the PCB process control block, page is on the backing store, either that page is available in the disk. If yes, that page is available in the disk, then bring that missing page into the physical memory. What is physical memory? Physical memory is the main memory. So free the frame for that particular page which is demanded by the CPU. After freeing up that particular page, there should be a content which is demanded by the CPU that comes from the disk, comes from the secondary memory. When that free frame contains the particular page which is demanded by the CPU, then it reset the page table. Means reset the page table means it makes the entry of that particular frame which contains that page. So new frame is available, and with the V it reset the value of that particular availability of that particular page which is demanded by the CPU. After that, it restart the instruction. Then CPU checks the availability of that particular page. In page table it shows that V is available, which shows that now the page is available in the main memory. So this particular process is called how to handle the page fault. Now the next topic is page replacement. Page replacement algorithm technique using the operating system decide if the memory is swapping out between the pages and the need to be allocation. Means if we have the content, how we can swap the particular values and to assign the new values in the pages for using that particular, for executing that particular process. Page replacement is simple, that some process which are executing and some new demands are generated. So how we can adjust that new demands in that particular memory, main memory, and how to allocate the new pages, how to deallocate the old content of that particular pages, that can be discussed in the page replacement. Though I am going to discuss about the algorithm. First algorithm is for the page replacement is FIFO, which is first in first out. Suppose we have the given string 701203. This is the string, and we have to adjust that string in the three pages, in the three frames, F1, F2, F3. Fine. So how it will be work? First 7 would be entered into the memory, so 7 will be entered. After that the F1 0 will be entered, 7 will continue, 0 will be entered into the next frame. Third is 1, so 1 will be entered into the frame. Now the next is 2, means each time when 7 entered, new entry is made, that is called page fault. Page fault means that is not available in the main memory, that will be comes from the disk memory. 0 is also not available in the main memory, 0 is also come from the disk memory. So this 0 insertion is process is called the page fault. Similarly, 1 will be inserted in the main memory, that will be come from the disk, from the secondary memory. This process is also known as the page fault. After that, now the 2 comes. So already we have entered three values in the pages, and pages can only occupy the 3 values. So now how we can enter the another value of a string in the memory? So we use the process first in first out. First in first out means the particular string, the content which is entered first, that should be deleted from that memory. Not deleted, it will be copied into the disk memory, into the secondary memory. Means 7 will be copied in the disk memory and 2 will come from the disk. I will show you in the, let's see over here. 7 will be copied into the disk and 2 come from the disk to the main memory. So this type of processing is again called, what we called it as a page fault. So 2 is arrived in the place of 7. Why we delete copy 7 from here? Because 7 is the first who is inserted into the main memory. So the number which is first inserted, that should be first out. This FIFO algorithm behaves in the manner first in first out. So 2 is entered into the memory. So now given string is 201. Now the next number is 0. 0 is already present in the memory, so no dispatch from the disk. It means 0 is already available in the main memory. So this 0 availability is called the hit. It means the page hit, that particular content is already available in the memory. In the same manner, now when I'm going to insert about the 0, so 0 is already available. Now I'm going to insert the 3. So for entering the 3, which number should be deleted, which number should be copied into the disk? The last entered number is 201. So 0 is the first which will enter in 20 among 201. So in place of 0, 3 will be inserted. Let's see over here. In place of 0, this is 0. In place of 0, I have inserted 3. In the same manner, this process will continue, and all the string whichever first in, that should be first out. So in this way, all the particular string should be entered into the memory. So this algorithm is called first in first out for page replacement. So how we can get the page hit? The number of content which is already available in the main memory, that is called hit. So the number of page hit is 3. And page fault, the content which are newly entered, which are copied from the disk, that is called page fault. So it has page fault 12 and page hit 3. So hit ratio is number of hits upon total number of reference. Number of hits 3, total number of reference, page fault plus page hit 15 into 100, it is 20%, which is hit ratio, and page fault ratio 12 divided by total number of reference into 100, 80%. So for accessing the process which is good, when the hit ratio is more than the page fault ratio, that process is considered as a good process. But in this process, the page fault ratio is more and hit ratio is less, so this is not should be treated as a good process. A good process which is having more hit ratio in compared to the page fault ratio. So that's all from the today's lecture. In the coming lecture I'm going to explain about the more algorithms of page replacement. So try to make understand these all the lectures which I have already inserted in the PPTs. I'm going to share this view and you can easily access. If you have any query, you can write over the group or you can personally WhatsApp or mail me.